Hello everyone, welcome to another video. In this particular video, we're going to see how calculations for specific charges is done, and then prior to that we'll also talk about what specific charges are. Okay, so this is contained in AQA A levels, so let's jump right into it. A characteristic, a feature of a property of a substance. Okay, it's more like saying specific heat capacity is the energy, or let's say it's the thermal energy needed to raise the temperature of 1 kg of a substance by 1 degree Celsius. Those are specifics. Okay, that's a particular property of a substance. Now for charges too, it's the same thing. Okay, kind of similar anyway. Specific charge of a particle is the ratio of its charge to its mass. And let me show you, it's as simple as what you have on your screen. All you have to do is just to divide that charge by the mass. That's all. So once you know what the charge is and you know what the mass is, you're good to go. Specific charge equals charge divided by the mass. And how about the unit? The unit of specific charge is coulombs per kilogram. Okay, so how did we come about that? Specific charge is the symbol, charge is Q, mass is M, and charge is measured in coulombs, mass is measured in kilograms, and this is coulombs per kilograms. It's that simple. All right. So we have a question here that says an atom of magnesium gains 2 electrons. What is the specific charge of the ion? First things first, the magnesium and we're working with here is magnesium 2412. The second thing, you write out the equation for specific charge, which is charge over mass. Okay, and that's Q over M. Okay, now the next thing is you check what you're given. How many protons do you have in magnesium? Let me just state, in case you're having issues with that the atomic number gives the number of protons in an atom or in an ion, as the case may be. So what's the atomic number here? The atomic number here is 12. So that means you've got 12 protons in magnesium. How about neutrons? To get the number of neutrons, you just do atomic mass, or what we call mass number, atomic mass minus atomic number. Yeah, there are so many ways by which you can get the number of neutrons. Okay, but we're sticking to this here since we will have whole numbers. So atomic mass is 24, atomic number is 12. So number of neutrons, you have 12 neutrons as well, 12 protons and 12 neutrons. Now the next thing on the cards now is to calculate the total mass. Now how do we calculate the total mass? What equation is applicable to that? So to calculate the total mass, all you're working with is total mass equals the nucleon mass number times mass of one nucleon. By nucleon we mean particles in the nucleus. That could be protons, that could be neutrons. okay, excluding electrons. Electrons, you don't have electrons in the nucleus, okay. So the mass of one nucleon, the mass of one nucleon, we have it as 1.67 times 10 raised to the power of minus 27 kilograms. Okay, so when we slot that into this now, you know, mass of one nucleon, that's what you have here. This will be 24. That's the mass number. That's 12 plus 12. That's how we get the nucleon mass number. That's 12 protons plus 12 neutrons. This is all you have in the nucleus. Okay, that's why we have it, the nucleon mass number. We can as well have it as mass number anyway, but just for the sake of explanation, that's why we have it as nucleus mass number. So if you do 24 times 1.67 raised to the power of minus 27, we wrote that earlier, that should give us let's see, 4.0 times 10 raised to the power of minus 28 kg. All right, and then step 5, we calculate the total charge. You know, we have the total mass now, and what we're working with is the total charge divided by the total mass. That's what we're working with. So we have the total mass now, and we need to calculate the total charge. So how do we calculate the total charge? Total charge is equal to the number of electrons times the charge of electrons of an electron is 1.60 times 10 raised to the power of minus 19 coulombs. Okay, so you substitute how many electrons do we have. Now let's go back to the question. An atom of magnesium gains two electrons. The number of electrons will be 2 times the charge, 1.60 times 10 raised to the power of minus 19 coulombs. And this will definitely give us minus 3.2 times 10 raised to the power of minus 19 coulombs. Now we'll have the total charge. So all we do now is to substitute. Remember, specific charge equals total charge over total mass. So this will be, the total charge is minus 3.2 times 10 raised to the power of minus 19 coulombs, and this is minus 19, and then the total mass, what's the total mass? We got that earlier. That's 4.0. That's 4.0 times 10 raised to the power of minus, is that minus 28? Yeah, minus 28 kilograms. And this, a final answer will be minus 8.0 times 10 raised to the power of 6 coulombs per kilograms. Okay, so guys, one thing I just want to point out is, if the question says the ion gains electron, or the atom gains electron, the charge, the value of your charge will be negative. But if the question says the atom loses electron, so gains, that will be negative. If the question says the atom loses electron, that will be positive. So if it loses electron, that will be 1.6 times 10 raised to the power of minus 19 coulombs for the charge you're working with. But if it gains, like what we have for this question, is minus 1.60 times 10 raised to the power of minus 19 coulombs. Okay, so that's it, guys. Thank you very much, and I'll see you in the next video.